Hello everyone, welcome to this video on using motion to find what you can't see. Here's the general setup. As you can see, we have a ramp that's made from a block of wood and a ruler. There are 4 sizes of ball bearings: small, medium, large, and extra large. There's a box that has a grid on top, and the grid is labeled A, B, C, D. Underneath the lid of this box, there is a magnet. The magnet is taped just to the underside of the lid. And for this activity, you can use any size, shape, strength magnet. You can use 1 to make it even more interesting. You can use 2, but those are taped underneath. And there's also a catcher lid here at the end or at the back of the box, and that's for ball bearings that are eventually going to be rolling across. A set of pins, colored pins, and then the students also need a data sheet that looks just like the one that's on top of the box and labeled in the same way. The purpose of this activity is to help students understand how scientists can use subatomic particles as probes to help them systematically learn more about the subatomic world. In this case, the probes will be our different size ball bearings. As you know, ball bearings are made of steel, which are attracted to magnets. So as the ball bearings roll across the top of the box, they're going to interact with the magnet that's underneath in different ways and produce visual evidence for students to help them understand more about the unseen object that's underneath. Explain to students that they are not to open the box and that the surface of the box is off limits to them. For example, students might want to take a ball bearing and feel around on the surface of the box to feel for an attraction to something like a magnet. Tell students that this is off limits. Start by having students examine the ball bearings, and they can choose one to start. Later on, students might find that different size ball bearings produce different results. So encourage them to have a conversation about advantages and disadvantages of using ball bearings, the different size ball bearings for this activity as they're working. Students should select a ball bearing. So right now I have the large one, and the ramp should be within the black border on the box. Make sure that the data sheet is kind of oriented in the same way as the grid on the box. If students are working in groups, they might assign each other roles. One person might operate the ramp, another person might collect data, another person might catch the ball bearing as it rolls off the box. So I'm going to release the large ball bearing from the top of the ramp, and students can choose where they want to release the ball bearing from. And that's another conversation that students can have. They can discuss what the advantages are and disadvantages of releasing it here versus there. But I'm going to release it here. The ball bearing rolls across the box, and if you notice, it made a slight curve. Okay, so on my data sheet, I'm going to draw the path of that ball bearing as best I can. And so you'll want to encourage students to be very observant so that they're as accurate as possible when they're drawing the path of each of the ball bearings on this chart. Now, encourage students to conduct trials all the way around the perimeter of the box first. Okay, now in total, students will need to conduct somewhere between 150 to 200 trials in order to get a good idea of, get enough evidence to be able to come to some conclusion about what type of magnet is underneath, or the size, shape, and location of the magnet that's underneath the box. Now, students will need to conduct between 100 and 150, or even more, up to 200 or so, trials in order to collect enough evidence to make some inferences about the location, the size, the shape of the object that's underneath this box, or underneath the lid of the box. So encourage them to do as many trials as possible. A lot of times students will want to do trials around the perimeter first and then stop, but push them to keep going. And so again, I'm going to move it over to the next block, and I'm going to release again. And again, you see that curved path that the ball bearing took. So I'm going to draw again that curved path as best as possible. All right. Now, when students have conducted their trials around the perimeter, they're free to, be a little bit more creative. Like if they notice activity within a certain area and they want to focus on that area, they could angle the ramp and, release the ball bearing, focusing on, so it focuses on that particular area. So they can, orient it in any way they want to help them get data that's going to be helpful to them when they start to make inferences about the object that's underneath. Once students are done, their data sheet should be densely saturated with lines, especially if they've conducted 150 to 200 trials. What you want to have students do at that point is use a marker or colored pencil and really try to draw in where they think the object is, and be specific about its size and shape and so forth. So for example, if the students thought, if all of the lines or the data indicated that there was a magnet here, then the students would draw that in. Once students have made their inferences and conclusions and they've drawn in where they think the object is, feel free to let them see the inside of the box, let them open it, and they can see how close they were. Okay, so in this case, the magnet is right here. At this point, have a discussion with students about how the data they collected led them to their conclusions and how close they were to the actual location, size, shape of the object. And also make some connections to the work that's done by physicists at Fermilab as they explore the unseen.